Effect is supposed to be a boring project in the sense that it should cover all of the things that you don't like to cover in an usual project. We feel like when you get to develop, most of the people like to focus on features. If you're building a product for users, your users are really caring about what you ship and so on and so forth. But the reality is, when you start, you usually don't notice huge issues. But as soon as your system grows and as soon as your user base grows, what used to be an edge case that happened maybe once every month now is going to happen multiple times per day, because with increased amount of traffic, increased amount of troubles along the lines. And usually at that point, you need to start dealing with things such as observability, error reporting, metrics, retries over network operations, and so on and so forth. And all of those concerns really have nothing to do with your product or your application feature-wise. They are on the side. What happens is, at that point in time, you're going to introduce those concerns in your code base, and your code, from looking like it's only caring about the happy path, it's going to look like it cares about everything else but the happy path. I've seen code bases that integrate observability and so on and so forth in plain TypeScript. It's a nightmare of nested try catches, and you're going to tap into type unsafety because you don't really have typing over error channels, typing over dependencies, which you need. Well, you need dependency injection if you want to test your software, but many of those solutions are really not type safe in the sense that they don't make the types explicit in your code. So you end up with this nightmare of untyped JavaScript, which only hurts because then software is never perfect, is never done. You always have to add features to the code, you have to refactor stuff, and an API that you call changes over time. So the software is never finished. And that means you have to maintain what you've built and you have to extend what you've built. And all of those concerns that you added to your code are going to make those operations very hard. So I've seen from experience a lot of code bases that get to a point, we call it tech debt, gets to a point of tech debt where you can't make any change. And you're scared to make something because you add the feature, you break something else, and the code becomes really, it's almost like it remains in this state where it works, but we don't really know why it works. And when it doesn't work, we might have some ideas about why it doesn't work, but it's all a mess. And Effect is really to resolve that problem. The compromise is you're going to have a little bit of work to do up front. There's an amazing talk that I rewatched recently by the author of Closure, which is called Make Simplicity Easy or something like that. I can provide the link after, where he makes the point that something simple and something easy are two different things. Like TypeScript is easy. You can adopt it very, very fast. You already know it. And there are a lot of libraries that doesn't take a lot of effort to adopt those libraries. But the lack of effort is something you're going to have to pay later. And something simple has an initial price because you're actually thinking about what you're doing long term, but then it's going to require less and less effort as you go through with it. Effect is like that. Effect is a solution that is going to require a little bit of thinking at the beginning, little bit of learning curve. That's the trade-off to make things maintainable at scale and to allow you to update your code with ease and with fine sleep at night. There's a lot of people that are using Effect that are jokingly say that Effect affects their sleep, because now they do sleep. Before they did not sleep. And yeah, that's Effect in a few words.
So the way you started talking about it, it kind of first sounded like it's going to be the level of like JavaScript, where it's like, because the way you started talking, it sounded like, okay, it brings all the features that you need for like a production grade application. But then you kind of shifted, and the way you described it is more like way low level. You're more like providing like really like a solid foundation for applications to build on, like on a primitive level, not on a feature level. Is that a fair-ish statement?
Yes, effect can be considered and should be considered for the purposes of many discussions as a language almost. I call it an embedded language within TypeScript, an embedded domain-specific language. It is very low level in the sense that it's as low level as a promise, pretty much the same level. But there's a full set of, almost like a framework, which is built on top, which is all provided in a way that is composable primitives. It's almost like NPM. You don't need to know the full of NPM to use TypeScript. You use TypeScript and then you plug in one more library to resolve one issue, and so on and so forth. Effect is very similar. The base is a general purpose programming language, which is embedded within TypeScript, and then there's an ecosystem of tools that is provided on top of Effect. Lately, we've been focusing on durable workflows and clustering, which is similar to, an Erlang Beam for TypeScript, or an Akka clustering solutions for TypeScript, plus an embedded temporal built on top of it. So we are going higher and higher levels in the abstraction chain, to the point where it's going to be very close to your app in the sense of fully fledged framework to do general purpose programming. But the baseline is a very low level system, and I really believe it has to be low level, because I think JavaScript is broken at the lowest level. So that's where we have to intervene.
Okay, I need you to elaborate on that. I mean, the fact that JavaScript is broken, I think, just as a blanket statement, most people will agree on, but mean very different things.
Yes.
Tell me through this. What do you see is missing? And I assume, from your perspective, Effect.ts is going to fix that for you.
This could take a podcast on its own to discuss why JavaScript is broken. I think the async story of JavaScript has gone through different iteration cycles. It all started with callbacks, which we call in theoretical terms that CPS, continuation passing style. Continuation passing style was too hard on JavaScript people to understand, so we call it callbacks. But really, it's a model that goes back to the 60s and the 70s, where you don't program in terms of statements, you program in terms of function that ends up calling the continuation you pass in. That model is actually a model that unifies both synchronous computation and asynchronous computations, and it's a model where errors are typed. So we initially had, the first iteration of JavaScript, had a model that unified synchronous and asynchronous computation, and that had type errors. But then we introduced promises. We introduced async functions. And then we made some odd choices. First of all, promises don't type the error channel. So you don't really know what a promise can reject. The second thing is we made promises strictly asynchronous. So if you program in terms of promises, you program in an async way. Your sync code looks different from your async code. That's the problem of function coloring, which many other languages have taken inspiration from JavaScript and onboarded the problem on themselves. And we've seen iterations and iterations of programming languages make these kind of decisions. And really what it means is you have a code base which kind of looks schizophrenic. You have untyped errors everywhere. You have parts of your code base which is strictly synchronous, part of your code base which is strictly asynchronous. And if you change a small thing in the very bottom of your code, and that has to be async, and it used to be sync, it bubble ups to you have to change everything, and that has a performance cost, and so on and so forth. So I think Promise was really a bad choice for as a programming model in JavaScript.
I agree.
We've lost the unified representation of code. We've lost typed errors that we had with CPS. I'm not saying CPS was a better user experience.
No, I got that.
The user experience was awful.
Yes.
Horrendous, horrible. Use any term that you want. It was not pleasant to use, but at least you had those traits that then you've lost for the sake of writing your code in a way that looks like a procedural code. Well, there's a better way of doing so. With effect, we also, by using generators, we can simulate async await syntax like, so you can write in a procedural manner, because programmers like to think in procedural manners, imperatively. I like to think about software as an algorithm where, my program starts, it does this, it does that, then it, if this, then that, a while loop. All those constraints are embedded in our mind. We don't think in terms of higher order functions, folds, and all the craziness. We could think in those terms, but I at least leave the unfortunate reality of having done more than 15 years of object-oriented programming and imperative programming. So my brain is sort of wired in that direction. I'm not naturally thinking in terms of composition of functions and so on and so forth. There's a better trade-off where you can still get the imperative mindset, but don't lose the unification of representation of code between synchronous and asynchronous work. You can have typed errors, and you can have also typed dependencies. And by making the smart promise, which we call an effect, lazy, which means if you create an effect, nothing runs. The computation only runs when you actually run the effect. With a promise, the moment you create the promise, the callback you pass into the promise, it gets executed at the next tick, but it gets executed. You don't have control over when that portion of code gets executed. This also allows us to provide ways. For example, you can have an effect that calls an HTTP server, and at some point in the future, you say, yes, but I actually want to retry all the transient error on that call. And you still get an effect. It's highly composable, and by being a pure description of an operation that never executes, only executes when you explicitly say it, so you can modify it. And this gives you superpowers, because we embedded there stuff like telemetry out of the box, stuff like metrics out of the box. You write a program with effect, we can print out a full dashboard of what went wrong, and so on and so forth. So that's what I mean when I say JavaScript is broken at the deepest level. The model of programming you use in JavaScript is broken. And this is also something that a lot of people complain about, because they say effect is completely different. It has to be. If it wasn't completely different, we would be using the broken model, and we could not build something that actually scales to the level of production-grade systems.
I think, honestly, that's probably my biggest concern that I have with promises and async and wait in general, because it looks so easy and natural, but there's such a complexity of like how things work. And the minute you start like properly handling errors, it's like you're in for such a ride. Yeah, literally, it's horrible. And I have not seen a single code base with async await where I couldn't like within a second spot an issue. And it just needs to be a
you have
function
to
that
add on
runs
top
twice.
of that interruption, graceful shutdown.
Yes.
Because in reality, when our programs are mostly distributed, they run on stuff like Kubernetes, whatever.
Oh boy.
If you kill a container, the container has to go down. You don't have to leak all open sockets and everything else and forcefully shut it down by blocking locks on databases and so on and so forth. And once you start to introduce those concerns like interruption, like error retries on the async await model, that's when troubles comes in. Async await is perfect for the happy path. It sucks for everything else.
Yes. I think the first time I got made aware of effect.js is when people started to compare it to RxJS, where like the minute you like read the documentation, you realize that it's like completely different things. But there are a lot of things that you said.
They say it quacks like a duck, must be a duck.
The thing though that you said, like the constraints and concerns that you tackle with effect.js are kind of similar of like the primitives that we try to establish with RxJS, where it's like a unified model for synchronous and asynchronous code, being able to handle constraints like retrying and those things. So from that aspect, in the end, RxJS went more the CPS route, whereas you went more the iterator or async iterator route, kind of like IXJS did. But I'm curious if like some of the design of effects was inspired or in some way by RxJS.
So my biggest gripe with RxJS actually has nothing to do with the concerns that it tries to resolve.
Okay.
My biggest gripe with RxJS is the fact that it tries to pretend everything is a stream. And that comes at a price, in the sense that it doesn't have a representation of one-shot continuations. Every continuation might be invoked multiple times.
That's true.
Which means you cannot put on top of RxJS an imperative API. We, by the way, don't use async generators. We don't use iterables. We use plain generators, because for us, a generator is simply a way of composing effects.
Okay.
But here we're going to go deeply technical for a sec. In software, in programming language design, there's a thing called delimited continuations, and there's a thing called full continuations. Full continuations can represent multi-shot effects like RxJS and provide an imperative API on top. But that requires everything being immutable. That's stuff like, for example, that Unison has. Completely unknown language, mad science, amazing, very awkward to use, but amazing computer science. I know Paul, very smart guy, the original creator, but delimited continuations are kind of half-assed versions of continuations where you have a mutable thing, a mutable state, and those can only represent single-shot effects. They cannot represent multi-shot effects. So with RxJS taking the route that everything is a stream, which is a unified model because everything could be represented as a stream, the price is you lose the ability of having imperative representations of your code, which makes it really hard to use for the average mindset of a developer. That's my biggest gripe with RxJS. Nothing to do with the concerns we cover. I don't like the fact that observables don't have typed errors. I still think that's a bad design. But apart from that, it's a lazy model. You invoke it whenever.
Right, exactly.
There's a lot of similarities in the story. But this is where we fundamentally diverge from RxJS. We don't say everything is a stream. We have a stream primitive if you want to do multi-shot, but we have one-shot effect types that allows you to program in a normal way.
One of my biggest issues that I have also with RxJS, but also with async await, is with how contagious this is. Because basically, the minute you start to use observables somewhere to get the benefit of composability, everything needs to be observable.
Yes.
The same with async await. The minute you start async await, then, well, your function becomes async. Well, then you need to await it in the other function where you used to call it.
Yes.
So those paradigms are very contagious. That's how I like to look at it. How's that for effect.js?
Same. Effect. We say that effect is a virus. It spreads towards your code base, but we think it's a positive. We don't think it's a negative.
That's what I was wondering, because like it kind of forces you to consider the error cases and those things.
Well, I mean, we do have interoperability with promises, so you can run an effect as a promise, and especially for the purpose of incremental adoption in a code base, we have companies like X.com, which is now using effect. We have companies like Vercel that is now using effect. You cannot think that those companies just go on and rewrite the whole code base to use effect. It's not a one-shot migration.
To be fair, like with all the issues we've seen in X recently, I wouldn't be surprised if that was going on. But off topic.
They should, but this is a different topic. It's unreasonable to think that they would do a one-step migration to a completely new system and just stop delivering features for 6 months. That's unreasonable. They have to adopt something step by step. That's incremental adoption. The incremental adoption path with effect is you run effects as promises. And once you run effect as promises, you're going to have to jump in and out of the effect runtime at the right places, but it allows you to integrate progressively. But the real end goal is that you will remove all of those integration steps once you're closer to the point where you can do the one-step migration and turn the main of your program from being an unsafe promise to being an effect. At that point, you're full in, and that's the objective of effect. So many call it a primitive that leaks into your code. No, that's wrong. It's a primitive that is designed to leak in your code. It's different. It's not that this is by mistake. We could have made a different primitive that doesn't leak in your code, but we would have achieved 1% of what effect does.
To some extent, you already answered my next question, but I am very curious on this discussion about typed errors, because like the web as a platform decided against it. Everything is unknown, and in the best case, if you use like more strict TypeScript compiler settings already, otherwise it's just any. And I think for production grade systems, having a concept like type errors is important. On the other hand, what I'm wondering is, okay, is this trade-off that you gain, because at the end of the day, you need to handle every error more or less individually. Is that from a developer experience, like I'm looking at the trade-off between developer experience and production quality, right? Like, it seems very much like we're trading very much towards production quality and have like a very tedious system to maintain.
Well,
how do you look at this?
You're sort of pointing to a very interesting discussion. In effect, we have two types of errors. We have typed errors and we have defects. Defects are non-typed.
Like runtime errors that just happen that you weren't aware of.
Or errors that used to be typed, that at some point in your program, you say, I no longer care about this. For example, you have an HTTP call. Is it inconceivable that this HTTP call may fail because the server is down? No, it's normal business day. Then you apply a retry policy on it. You say, I wanna retry with exponential backoff up to, I don't know, 5 seconds, up to a minute. This depends on the business logic that you are implementing. There's no one solution that fits every case. You have to decide the boundaries of your retry and so on and so forth. But once you've retried everything and you cannot do this HTTP call, is that an exception, or is that or that remains as an error? I think at that point, if you've done everything in your ability to do, you might just want to fail, and that's it. Call it a day. That's when you transform a typed failure into a defect. So the typed part is only for things that you are explicitly handling. So if I want to handle it, I have it typed. If I don't want to handle it, I don't have it typed, which means I have typed control flow for the things your code cares about, and untyped bubble-up semantic for things that you don't care about. So this is where the trade-off sits.
I like that differentiation a lot, because it also makes it very clear of like, okay, this is the point of last resort, where it's like, okay, I really don't care about this anymore. Just let it fail.
Just crash.
Yeah. Yes. I like that a lot, because it makes it very explicit. I'm a big fan of like structuring your programs in an explicit way. Like I like in a former life way back when I did Ruby on Rails a lot. And like from the convention aspect, I loved it, because like when you know the conventions, it's like, oh yeah, super easy. But like the starting experience and like not knowing those conventions, it's horrible. And like the level of magic that you can do in Ruby in general is just, it's nice if you understand it, but it's just too much. So
it's nice when it's no longer magic.
Exactly, but like the point of getting to it's not longer magic. It's very painful. So I grew very fond of this idea of like being as explicit about your code as possible, and that sounds very much to me like what you described of like, okay, in line 73 of our code base, we convert a typed error to a defect because we don't care at this point anymore. And I like this approach, because I unfortunately never had the chance to work in a fully error typed code base. So this is just based on assumptions and like experience, right? Experience on the other side of the end. How I imagine.
Well, I mean, the fully typed version also have problems, because many people say, for example, typed errors are bad because we know in Java, checked exceptions are bad. Sure, because you don't have this differentiation. Either of the opposite sides is bad.
Yes.
You need explicit typing to help you, to help the IDE telling you, look, here you have an error which you might want to deal with. And if you have an error, you might want to know the type, because, we like types. Otherwise, we would use JavaScript instead of TypeScript.
Right.
But to a point, I don't need to see that a computation fails for 150,000 different reasons, and that just makes my type extremely verbose, and it doesn't convey any information.
Yeah.
So you need this differentiation between typed and untyped errors, and most importantly, like, this is also something that was discussed in some TypeScript PRs. Some people were thinking of like, okay, let's just introduce in TypeScript some way of saying this function can fail for reason A or B, and then your error would be of type unknown or A or B.
Yes.
Well, unknown or known is unknown. You're not gaining anything. That means your catch logic, you need to be able to say, I want to catch a typed error of the specific type X. And everything else, let it bubble. This is also very important. Otherwise, it's not enough to know that a function may fail for a reason if it can also fail for an unknown reason.
I mean, it goes a little bit in the explicit direction, but in general, I agree. I see where you're coming from.
Like at the type level in TypeScript, if you type unknown or whatever else, it's going to resolve to unknown.
Yeah. How is that handled then in effect.ts when you're like crossing the boundary to the web platform that just throws an arbitrary error that is unknown in best case?
It's up to you in the sense that it's the developer's decision. We by default fail with a cause type, which can represent any kind of failure. But for your flow, it might be that you only care about typed errors. So you say you want to return, for example, a result type of success or the typed error, and in any other circumstance, just throw. Or you might want to say, I only care about the successful type and not care about any other scenario. So throw in any other scenario. It's the choice of the developer. And it's also one of those places where verbosity comes into play.
Yes.
Because you have to decide. Once you've decided, it's fine. But it forces you to think, okay, what do I do here? Do I care about this? Do I not?
Yeah. One thing that I mentioned it before to you that I want to talk to you is your open source business kind of thing. Because I think this is always interesting. Every open source project has kind of like a different business model at the end of the day. Some just rely on sponsorship. Some have an open core model and then build like either a paid library on top of it, a platform model, a SaaS, something like that. Where is effect.ts on that scale? How do you run effect.ts? That is basically my question.
So let's... I'll say something which I might get into some trouble, but I don't think open source is a business. I don't think open source can be a business.
I have blog posts on that, so I agree already.
And I think we live in an unfortunate society where there's a huge conflict of interest. We perceive developing libraries as a mean to earn money. You're not going to make money out of open source, period. You have to realize that. And if your business is living out of sponsorships, not going to get sponsored. You might get sponsored for a few months. You might get sponsored from time to time. It's an unreliable source of income at best.
Agree.
At worst, it's a way for you to lose 20 hours per day out of 24 and just get burned out. So let's start with that.
The way that I like to think about it is that open source is kind of a way for companies to exploit the passion of developers. Because a lot of us developers like working on open source because it's a creative outlet, it's a way to experiment, it's a way to tackle problems that we see on a daily basis. But at the end of the day, other than like the passion aspect, developers itself don't benefit from it. At the end of the day, it's a company that benefit from that. So I 100% agree with you. Keep going.
And the other side of the spectrum, which is not plain developers building libraries, even worse, companies building libraries. Now you might say, but you're doing that. Guilty as charged. I think the model is wrong. So, and here we get to the point of why Effect was made in the first place. So the reason Effect was made in the first place was I was CTO of a fintech company that had nothing to do with open source whatsoever. Not our business to do open source. Our business securitizing loans and reselling loans to institutional investors. Boring for tech purposes, exciting for other purposes, but
I was just saying, from a financial aspect, sounds pretty good.
From a financial standpoint, very exciting. For anything else, very boring.
Yeah.
We had to build boring software. We needed a boring solution. Ended up being Effect. Once I realized that the way really solved our issues, I was like, there's probably hundreds of thousands of developers suffering from the same issues that I am suffering, and it's not my business to maintain this piece of software. So let me open source. the piece of software. That's why Effect became open source. So it started as a project to resolve a pain point that I had, and was open sourced as a way to relieve the same pain points into a larger ecosystem. And one thing led to another. The project grew, and at some point, I got bored with finance because it's hyper regulated. It's painful to work in. I was a regulated person. That means owning a trading account would cost me $10,000 per year, because I could reuse the data for the business side. All boring, and I was like, I really like tech. I started programming when I was 11 years old. I still program to the day after more than 20 years. I feel old, but it's pretty much crystal clear that I like the world of tech. So I decided, let's make a consulting business, which I had as a side business from before, and let me maintain Effect as part of my side business. That's the first iteration of Effect getting closer to a commercial element. But there are other ideas that I feel very strongly about, and those ideas are only partially related to Effect. And it's more along the lines of the world of technology being misguided into thinking serverless is an amazing solution for 99% of the problems. I actually think it's a very dumb solution for 99% of the problems. It's a fantastic solution for the 1%. So this has nothing to do with Effect in first principle. Just so happens that Effect provides durable primitives. Effect really helps you in building distributed systems. So once my conviction that the world was truly misguided into serverless became strong, I decided to raise money for the business side, not for Effect, but for the business side, to develop the complexity that we have to develop in order to resolve the misguided element of serverless in the world. Why people like solutions like Railway, Render, Vercel, and they don't like the AWS, the GCE, and so on and so forth. Why? Because the developer experience on the former is far better than the developer experience in the other. And it's not easy to get to the same developer experience by also providing the rest of the functionality. So we have to build a lot of complex software by ourselves. And that's why we maintain Effect. In a sense, we don't quite care if other people use Effect. We do, because, of course, if you use Effect, you're going to care about interesting element of production-grade softwares. So there's a good chance that we might, once we are ready with our product offering, that we might convert you into a customer, into a paying customer of the cloud product or whatever we want to call it. But that side of the business really has nothing to do with Effect. Effect is still 100% open source, MIT licensed, and the Effect organization is not owned by Effectful Technologies Inc. as a company. It's still owned by me and the few developers that have contributed to it from day one. So it's still separated. And we don't have a registered trademark. Once you contribute to Effect, you don't have to sign any CLA or any sort of thing. Effect is open source. So that's why I say I don't think open source is a business model. I think with open source, the good that you can get with open source that has business value is creating a community of people around it. Because, for example, for Effectful to hire people, it's never been easier. In my life, I've hired for many companies. It's never been this easy. I have not done a single interview to hire the people that are now running Effect.
Yeah.
I knew them from before. We've been cooperating for years before the formation of Effectful. So that's huge value. And also if you have a huge community that is all passionate about production grade software, you can throw at them ideas and you can get back feedback that tells you if you are dead wrong or if you might be on the right track. And if the community is large enough, that can be representative of a larger market. So there is value in running an open source project, but not as a business model in itself. And I also believe that projects where the commercial product is just a hosted version of the open source project, I think even there you have conflict of interest because you're gonna make it impossible to deploy on your own, and to a good extent you're just waiting for disruption from a true open source alternative that is easy to deploy. Like we are developing now Effect Cluster, which people say it's the closest element to a commercial product. Still 100% open source.
Mm-hmm.
The first two live demos that we have running, we have a script that allows you to deploy it on fly.io. We have a script that allows you to deploy it on AWS, and you can deploy it in whatever version of infrastructure you might like. Being easy to deploy is an essential element for something like Effect to succeed. So there's no, even there it's purely open source. Effect Cluster is a version of what you would know as, for example, Erlang, the Erlang Beam virtual machine for JavaScript, or in Java land it's similar to an akka. And on top of that, we also have a durable workflow runtime which uses Effect Cluster. So we're getting higher and higher, but in the levels of abstractions. But even the top level of abstractions are 100% open source. The thing that we have as a product, which are not yet public, are not open source. You don't find a repository with this code in it.
I think that makes sense.
And apologies for diverging into a tangent.
Okay, I do have to, because it sounds, I mean, when you say you raised money, like VC money is always like some kind of promise bet where you say, more or less, like overly simplified, you say, oh, we're going to have X amount of users and we need Y amount of money for that to make that happen. Very simplified, right?
Extremely simplified.
Yes. Most of the time, VC people that I talk to care about user adoption and the effect on like potential money that comes in with that. How did that go for Effect? Because the leap from like open source to like promising a product that's kind of a jump at the end of the day. I mean, you have a great background with like, okay, financial background is something that people always love, but then also like, okay, we built production grade system for years. We have a community of people that care about production grade system, and we develop a product that is fantastic for people building production grade application. But how did that pitch go at the end of the day?
Well, I'm going to say something else where I'm probably going to catch a lot of crap. There's probably the 0.5% of VCs are good VCs. Let's start there. Not gonna name names.
0.5 is already probably a high number.
It's already a high number. Yes, it's already a high percentage. I was being optimistic. The reality is, if you have any other way of running your business that does not involve raising money from VCs, do that.
Yes.
Okay. But there's a very good reason why VCs exist.
Also, yes.
VCs are for the ideas that if they go well, they have a chance of becoming the next Google, the next Microsoft, the next General Electric, the next huge corporation going public, making billions per year. And they are extremely high risk and low probability of success.
Yes.
I'm not going to reveal in details what we're working on with Effectful, but I think it's going to have, optimistically, a 5% chances of success.
Okay.
Optimistically. If that occurs, it is the next Google.
Okay.
Most likely, it will not. You need the right type of investors for this. Most of the investors are not right for this. Most of the investors just look at momentum, just look at numbers. Here you need investors that are deep into the thesis, and the thesis is TypeScript is going to become the de facto language for backend. Serverless is not going to be the solution.
Okay.
And we have a way of resolving problems that 90% of users, not effect users have.
Okay.
You need to be convinced of that to put money in effect. In Effectful as a corporation.
Yes.
Is effect important for Effectful as a corporation? Yes, of course.
Yes.
The community is fundamental. The people involved are fundamental. The feedback that we receive on a daily basis from design partners and so on and so forth is absolutely fundamental. So I'm not here to say numbers don't count. Yeah. I'm saying the thesis is fundamental. The right investors are fundamental. And the community aspect is very important. Once we picked the partner for our pre-seed round, first we only raised $2 million. We didn't raise 20. We raised 2. Yeah. And my business plan with those 2 millions was to have 5 years of runway covered.
Yeah.
The investors looked at me like I was a crazy person in a call.
Yeah.
It's like, 5 years? I might be dead in 5 years. Who cares? This type of business is a business that can take 5 to 10 years to develop. You need to be careful. Now, we are spending a little bit more than initially expected, but we have decided to do so because things are trending in a specific direction. That means we're not the kind of VC-backed business that is just about grow, regardless of where we point. The direction is fundamental. We have to grow in the specific direction. We have to develop for that specific direction. And once we will raise the next round, it's going to have to be on the same principles. We're not just going to... We had many opportunities to raise, even priorly to when we raised. We just had to pick the very right partner.
Okay.
In our case, the seed round is the pre-seed round is backed by Amplify Partners, which is a fund which is well known for infrastructure. Yeah. They have a deep understanding of those types of products. They're not here to rush. They're not here to force us into specific directions. They've been nothing but helpful for the past 2 years. Cool. And awesome. I've had no pressure whatsoever into we have to achieve some strong milestones. Like, we know where we have to go, and we decide how, and the following rounds will have to be on the same ground. But again, that's less than 0.5.
I do have one question to the thing that you said, because you just said that you believe that TypeScript is going to the de facto standard for backend. What makes you think that?
What makes you think of the opposite?
Okay, let's start maybe by the fact that things like Java and .NET are very well established in that area already.
Okay, let's say you're creating a new startup. Are you gonna pick Java?
Potentially, yeah. Yeah, I would potentially. The developer market is the highest, most likely. The amount of infrastructure, etc., is already there. I would not pick Java if it's like performance critical, where I'm like a stock something. I wouldn't like. Let's not go in that direction. But
I don't think in a company you pick a single language. First of all,
that is also true. That is also very true.
When you say I wouldn't pick Java for a performance critical company, well, stock markets, stock exchanges still have login systems, still have sending emails, still. Of course, you will not build a trading engine with JavaScript.
Yes.
Of course. But
yes,
the 90%?
I think I would probably pick Java or Kotlin. But yeah.
Okay, that's what I did in my old startup.
Mm-hmm.
And I was dying for many, many reasons. Very hard market to hire in. Front-end team doesn't know back-end team. Very hard to hire. Costs Java people cost a lot of money. Especially people that actually know how the JVM works. Not people who can just type things on the keyboard.
Yeah.
And you're going to have a full disconnect between backend and frontend, which, especially in small team, it's pure friction.
Sure.
Most of the new greenfield projects are about AI. And most of the greenfield projects are people build AI in TypeScript.
Yeah, I agree with that
They
too.
train models with Python, they do data science with Python, but then the primary interface that they use is TypeScript, because the concurrency model of the JavaScript virtual machine is a concurrency model which is optimized for IO-bound applications, and 90% of what we develop on a daily basis is IO-bound. Of course, for the 10% that is CPU-bound, memory-bound, you might want to pick other languages. I'm not here to suggest you should do data science in TypeScript, or to suggest that Rust and so on and so forth, they don't have a place. I do strongly believe that they have a place. I think the 90% plus of problems are better resolved with the concurrency model of the JavaScript virtual machine, which is much more lightweight compared to the concurrency model of Java with the JVM and so on and so forth. And once you talk at the lower level, then you constantly have to think about things that have nothing to do with the problems you resolve. For example, when you use Rust for business level code, I love Rust. I've built compiler in Rust. Wrong decision. Probably Zig was a better choice. I've built low level systems with Rust. Amazing. But you have to think about memory constantly. You have to fight the borrow checker constantly. And it's good, because then you get code which is highly efficient in memory allocation, it releases memory correctly, and so on and so forth. But if I want to take data from this database and push it into the other database, or answer to an HTTP call, I'm not thinking about memory allocation. I'm not at that level. And though thinking about those concerns materialize in code that is no longer close to the business. Your code should look 90+% about the happy path. And the other 10 less percent about the edge cases. That's it. I don't want to think about memory at every line of code I write, even if the result is memory safe and all the good that come from low-level programming. Plus, the market is huge. There's tons of people that know TypeScript, and a lot of misguided people thought that front-end is easy and back-end is hard. Nothing far from the truth. Front-end is extremely hard. Performant front-end is insanely hard, and people who have built front-end for ages are perfectly capable of writing backends. They just have to know the other elements, like databases and so on and so forth. like people who have created very complex backend systems might be able to create very complex front-end systems. They just have to know the other side, like interfaces and so on and so forth. The skill is there. And the amalgamation of everything is what makes me believe TypeScript is going to be the de facto number one language for both backend and frontend.
Interesting.
Which doesn't mean Kotlin and so on and so forth don't have a place. They do. Especially large enterprise and so on and so forth. It's funny because I had this argument with a lot of Java people 3 years ago. And they're like, Mike, you're crazy. Nobody's going to write backends in TypeScript.
Nobody is. I disagree with that as well. I disagree with that as well. I think it's a very viable option for years by now.
But it's funny because one of the best talks on effect was given by John Digo, which is historically a JVM guy, author of Scala frameworks and so on and so forth, who was of the idea that TypeScript was a terrible choice for backends for ages, up until the point where he actually realized it was a perfectly valid fit and changed his mind and gave one of the best presentations on why effect at Effect Days last year.
Yeah, you have to send me the link and I'll put that in the description of that. I'm very curious to see that. The thing that I was more stuck on is the statement of, okay, TypeScript will be the de facto standard for backend. I totally believe that TypeScript is a very viable option, particularly as you said, like in small teams, you definitely in small teams don't have the luxury situation that you have one dedicated backend person, one dedicated frontend person, and they are best friends with each other and know exactly how to communicate with one another.
But something that doesn't work with 3 people doesn't work with 300.
Yes. So from that aspect, I also had projects already with like TypeScript on the backend, and it works nice if you consider the edge cases and things. I'm not a big fan of general statements because I always like to see the flaw in those things. And it makes me challenge of like, okay, the de facto standard, are you sure about that? But I see where you come from. I think that's a very...
Now, again, I've said those are the theses. But then keep in mind, I think that we have a 5% probability of success.
Yes.
So everything comes with a caveat.
But I mean, to build a thesis, you need to have reason behind it. And you explained your reason behind it in a very sound way. So I can see where you come from. I like that.
Plus, you just can look at... I don't like this statement, but you can just look at the numbers.
Fair point. Fair point.
I'm more of first principle thinking, why will we get there, rather than just look at the numbers. But in this case, even just looking at the number kind of hint in the direction that at least it's going to be a very considerable part.
Yes.
De facto standard can even mean 65% of systems.
That's also fair. Yeah, I maybe exaggerated that a little bit in my thought process. Okay. All right. Michael, thank you so much for joining me today. This was a great conversation. I had a great time talking with you, and I hope once you launch whatever you're working on, I have you back and talk all about it with you. I generally had a good time. I really appreciate it.
Thank you so much for inviting me. It's the same here. I had a great time. And
thank you.
Again, there's something I want to compliment on that I've said before privately when we were not recording, but I also want to say it publicly. I really like how you're approaching podcasting and those types of unfiltered, direct conversations. I think it's important to have those. So thank you for having me.
Thank you so much. I really appreciate that. And everyone out there, see you next week. Thank you. Bye.
Bye.